Swayam Prabha. Digital India. Educated India.
Welcome dear students. So today in this particular lecture of Disperse system production, in this second lecture we are going to discuss various size reduction techniques, especially the various kinds of mills we are going to discuss. So let's enjoy this lecture after going through this the series of pharmaceutical production technology lectures. I'm again Dr. Ajay Similti, welcome you in this lecture. Let's start our lecture. What we are going to learn: what is the size reduction? What is the importance of size reduction? Mechanism of size reduction. Factors influencing the choice of size reduction equipment. You will be able to know what equipment you should employ for your size reduction. And what are the size reduction laws? The various types of size reduction machines we are going to discuss. As far as the lesson plan is concerned, with this particular lecture, we are going to discuss size reduction, their definition, their objectives of size reduction, mechanism of size reduction. Thereafter, we'll be moving to the factors influencing the choice of size reduction equipment, size reduction laws, and then various types of milling machines, size reduction machines. What does the size reduction mean? In simple terms, reducing the particle size of larger particles into the finer one. The operation carried out for reducing the size of bigger particles into smaller particles, one of the desired size and shape with the help of external forces, is called size reduction. The comminution is another term used for size reduction. Now let us discuss what are the objectives of size reduction. First objective of the size reduction is to improve the surface area, to increase the surface area of the particle. As we know, the most of the reactions involving the solid particles, the rate of reaction is directly proportional to the effective surface area or the area of contact with the second phase. When we break the material into very small particles in order to separate the valuable among the two constituents, the size reduction is required many times. We require the size reduction, we do the size reduction for achieving the intimate mixing, good mixing, to dispose solid waste easily, and to improve the handling characteristic. We do the size reduction. We do the size reduction to mix solid particles more intimately. More intimately we can do the mixing process, and that is utmost required in all the pharmaceutical industries, because we have to make a uniform blend of API with the excipients. Uh, so many kind of blends are needed to be prepared. So that's why the size reduction has got the importance and wider use. Content uniformity is the next, if you say the advantages, we can get the uniform content. The content uniformity can be achieved. Uniform flow can be achieved with the help of size reduction. If you do the size reduction, you will have good flow properties of that particular blend. Effective drying is possible when the size is reduced. Increased surface area or viscosity we will get when we do the size reduction, and this has its own advantage. Uniform mixing and drying, we can do improve the rate, we can improve the rate of absorption, because the smaller particles show the greater absorption Disintegration is the property. When you have seen the tablet as a dosage form, you see the first step is disintegrate, that it is must to disintegrate that tablet. The tablet is needed to be disintegrated into smaller particles. So overall, the smaller means the greater reactivity, greater point of contact, and hence the greater absorption. It improves the dissolution rate because the effective surface area is high for the smaller particles. So that's why they will go rather easily into the solution of the biological medium. So improved dissolution rate, good mixing, uniformity of the content, uniform flow, effective drying. So due to high surface area, we can have better absorption, better dissolution rate, and obviously the good mixing and good drying we can achieve. So these are the advantages of the size reduction as an operation. What are the limitations? Sometimes the drug degradation may be there, the contamination may be there, or some kinds size reduction increases the water insolubility, especially in terms of hydrophobic compounds. You might have seen that if you go for size reduction of the aspirin, so actually we are increasing the effective surface area of hydrophobic surface area we are increasing, and it results in increased water insolubility. So it is not always true that the effect more the surface area, more will the water solubility. Actually, it is a solubility which is incompatible with that particular inherent nature of that component. Okay. Now, what is the mechanism of size reduction? First is impact. Impact, particle size is reduced by a single rigid force. That's hammer. Hammering we do. It works on the principle of impact between the hammer and the particles to be reduced in size. So first mechanism is hammering, or you can say impact. Second is, now the second mechanism of size reduction is compression. What does the compression means? As the name suggests, we are crushing the material between the rollers, okay, by the application of pressure. We are applying this pressure on the two different sides and then compressing it. Then attrition. It is arising from particles scraping against one another or against a rigid surface by rubbing action. What we are giving the rubbing action here due to the abrasive forces. We can get the reduced size, and this is the method attrition. So first is impact, compression, third is attrition. The fourth is cutting. In the cutting, the material is cut by means of sharp devices. Okay, we can just cut the material. Okay, just like slicing, you can say. Now, what are the factors when we have studied the mechanism? Impact, compression, attrition. Okay, and then we studied that slicing, you can say, or cutting. Factors influencing the choice of size reduction equipment. Number one, feed and product size. What is the size of feed? What is the size of product? Depending on this, the size reduction equipment is selected. Second thing is, when we have seen this aspect of size of feed and product, the nature of material. What kind of nature of material it is? What is the feed and product size? For this one, for coarse crushers are used when we need the particle size in the coarser range 50 to 5 mm, and when we want to go for so for coarse crushers we go for 1500 to 400 mm particles. We can have 50 to 5 mm, we can have the lower range. Intermediate crushers, the range is 50 to 5 or 5 to 0.1 mm. Fine crushers may have the range from 5 to 2 mm to maybe to less than the 0.1 mm, while the fine milling, if you go for fine milling, 0.2 mm, less than 0.2 mm, rather than the micron size, we can move down to 0.01 mm with the help of fine millers or fine milling equipment. So this was about the crushers and the milling. So you can, depending on the size requirement, but the particle size requirement, we can go for the milling operation and the selection of the equipments for our milling or size reduction process. Now let's see the nature of materials. Uh, Hardness is the first nature. Very hard materials are better in low speed or low contact machines. With respect to the structure, the fibrous materials, uh, these fibrous materials need tearing or cutting actions, while the moisture, for the moisture content, materials with 5 to 50% moisture do not flow easily and can be difficult in process. If the material is having stickiness, sticky material need the easily clean machines. So you must go for the machines which can be easily cleaned. Okay, after the process of the size reduction. When the material is having the soapiness, if coefficient of friction is low, crushing may be difficult. For explosive materials, they need inert atmosphere. For the hazardous material, which are hazardous to health, they need the good confinement. So these are, depending on the material, we can go for the choice of equipment we have seen with respect to hardness, structure, moisture content, stickiness, soapiness, explosiveness, and hazardous to healthness. Okay, to these aspects. Now let's see the criteria for selection of a mill. First criteria is performance parameter. Second is capacity, energy requirement, then yield, ideal comminution equipment, high capacity, small energy requirement per unit product, because it is related to the cost. We have to see the cost effectiveness of the equipment or the entire process, and yield a product of single size or size distribution, or you can say uniform size distribution must be there. So these are the criteria that on the basis of which we can go for the selection of a mill. Now taking the performance evaluation, ideal operation is taken as standard one compared to the actual with compare the actual one with the existing one. Okay, uh, it's not feasible for crushing and grinding because of large deviation. The performance evaluation we cannot do. So, but empirical relations may be there when we are moving for the performance evaluation of milling. When we are moving for the size reduction, we must go ahead. We must be well versed with the size reduction laws. What are the theoretical laws? What are the theories behind the size reduction? So let's see them. These are the four major things you can see: Kick's law, Reittingers law, Bond's law, and Walker's law. So these are the four laws. Let's see them one by one. Kick's law. Kick's theory states that the energy used in deforming or fracturing a set of particles of equivalent shape is proportional to the ratio of change of size and diameter. So E is equal to K subscript K log di upon dm. This is the equation you can see, where E is the energy required for size reduction, Kk is the Kick's constant, di is the initial diameter of particles, dn is the final diameter of particles. By the wet, you can use this law for crushing of large particles. So for this particular reason or this particular area, the Kick's theory is most applicable. Okay. Reittingers law suggests that the energy required in a size reduction process is proportional to the new surface area produced. So you can see in this equation that EKR is into Sn minus Si, where E is the energy required for size reduction, Kr is the Reittinger's constant, and Si is the initial specific surface area, Sn is the final specific surface area. Okay, and you can apply in it is mostly applicable in reducing the size of brittle material. undergoing with the fine milling. Okay. Now let's move to the third law, that is Bond's law. Bond's theory states that the energy used in crack propagation is proportional to the new crack length produced. So it is, crack is the basis here. The E is equal to 2K into 1 upon square root Dn minus 1 upon square root Di, where E is the energy for the size reduction. Okay, this Kb is the Bond's work index, Di is the initial diameter of the particle, Dn is the final diameter of the particle, and this law is useful in rough mill sizing. The work index is useful in comparing the efficiency of milling operations. Okay. So this was all about the Bond's law. Let's move to the Walker's law. The Walker proposed a generalized differential form of the energy and size relationship. He stated that with expressed with the equation d is equal to minus k d upon dn, where E is the amount of energy work done required to produce a change, D is the size of unit mass, K is the constant, okay, K and small n is the constant for n, due to here in denominator you can say due to the power n, where n is equal to 1. Walker equation becomes Kick's theory. When n is equal to 1, the Walker equation becomes the Kick theory. Okay, this you should take in your mind. It is used for coarse materials less than 1 micron. N is equal to 1.5. If it is 1.5, Walker equation becomes Bond's theory. Okay, so this theory is based. This theory is used when neither Kick's nor Reittingers law is applicable. So we can use the Walker's law. N is equal to 2, the equation becomes Reittingers theory. So you can see that with the change in the value of n, if n is equal to 1, it is Kick's theory. If n is equal to 1.5, it is Bond's theory. If n is equal to 2, then it becomes the Walker equation becomes the Reittingers theory. So it is used for fine particles less than 1 micron. This was all about these 4 laws which we have discussed. The various types of size reduction machines, let's discuss them. That crushers, they may be jaw crushers, gyrate crushers, crushing rolls, they may be grinders, intermediate and fine grinders, hammer mills, impactors, rolling compression machines, ball mills, roller mills, attrition mills, or revolving mills involve the rod mills, ball mills, pebble mills, tube mills, and compartment mills. While the ultrafine grinders include the fluid energy mills and agitated mills. While the cutting machines include the knife cutter, dicer, slice, and slitters. Okay. Crushers. They may be coarse or fine crushers. Crushers are slow speed machines for coarse reduction of large quantities of solids. Crushers do the heavy work of breaking large pieces of solid material into the small groups. A primary crusher operates on run of mine material, accepting anything that comes from mine face and breaking it into 150 to 250 lumps. So larger lumps are prepared at the end product with the help of crushers. A secondary crusher reduces these lumps into the particles, perhaps in the range of 6 6 to 7 maybe. Okay. Jaw crushers, these crushers may be classified into jaw crushers, gyrate crushers, crushing rolls, and these crushing rolls may be subdivided into single roll or double roll crushers. So let's see them one by one. The jaw crushers. Jaw crushers. In the jaw crushers, feed is admitted between the two jaws. These jaws, toe jaws these are the set to form a V-shaped opening at the top. So V-shape opening we are having at the top. One jaw is fixed, just like our human jaw. One jaw is fixed and other jaw is movable. Okay. So that fixed jaw is called anvil. and it is nearly vertical and does not move, and the other is swinging jaw. It is the swinging jaw. You can say one is vertical and other one is moving. So you can say it like this. As you can see my hand movements, so it is moving like this. Okay, like, yeah, like this. You can say this way it is moving. The swinging jaw makes an angle of 20 to 30 degree with the fixed jaw and driven by an eccentric unit, thereby produce compressive force, okay, to lumps caught between the jaws. After required reduction, they drop out the bottom of the machine. The jaw opens and close 250 to 400 times per minute. So the frequency is 200 to 250 to 400 times per minute. Okay. Uh, let's see this thing in the this diagram. As we can see, this is the fixed jaw anvil, and this is the fixed jaw, and this is the moving jaw. The fixed jaw is vertical, and this is at the in the 20 to 30 degree Celsius 20 to 30 degree movement it is having this jaw, and this is the flywheel and eccentric shaft and bearing is there for the movement of this moving jaw, and the vibrating feeder we are having at the top of this fixed jaw, and it takes they are the reversible jaw liners there, toggle there, drawback rods are there, and the groove block assembly is there. So what is happening, that the product is being crushed in between with the help of the movement of the moving jaw at in the range of 20 to 30 degree, and by this way the size reduction is achieved. Okay. Now moving to the gyrate crushers, they work on a similar principle to the jaw crushers but have a circular gap in between them. Rock is compressed between a static conical bowl and a concave mantle which oscillates about the central axis. Okay. These are generally designed for primary crushing in large scale rock crushings, or can say application up to 6,000 tons per hour. So I'm just not talking about the pharmaceutical point of view. The raw materials can be, when we are having the raw materials. Say for example, you are going for the talc production. Okay, you want for the talc rock you are having. Okay, and you want to prepare from the rocks. You are preparing the talc. So you need the gyratory crushers kind of crushers. Okay. The load on the motor is nearly uniform. Less maintenance and low power per ton of material crushed is required as compared to the other crusher. That's why it is cost effective of power. You can say with respect to the power, it requires low power. The capacity of gyratory crushers depends. They depend the capacity of the depends on the capacity of a gyratory crusher. This capacity depend on the jaw setting. Okay, the impact strength of the feet and the speed of gyration of the machine. So jaw setting, impact strength of the feet, and the speed of gyration of the machine. These are the three factors on which this crushing uh, depends on. The capacity of crushing depends on. The capacity is almost independent of the compressive strength of the material being crushed. Okay. So this was about the gyratory crusher. Now let's see the diagrammatic representation of the gyratory crusher. The top shells, you can see the mantle, you can see here. Okay, the mantle diameter is there, and the bottom shell is there. The setting can be done here, and this way you can say the gyratory crushers. Please learn this diagram, and you can show with the help of ray diagram that how the working is being done, and this is the gap in which we are going to crush the material in the gyratory crushers. Moving to the crushing rods. What are the crushing rods? Typically, they are used as primary crushers. Impact, shear, and compression with the help of these three things. There are no screen bars here in these crushing rods. The clearance between the breaker plate and the rod determines the product size here. You can use this crushing rod or crushing rods like equipment for the petroleum coke, coal with raw coal, aggregate, limestone, chemicals, phosphate rock, shale, and many other chemicals. Now let's see, these are crushing rods. As the name suggests, these are the two rolls. Okay, two rollers are there in which is taking the material in between them, as the arrow is showing you. Okay, these are the screw which can be used for adjusting the machine. Okay, this is the machine frame is there on which these rolls, in the machine frame these two rolls are adjusted in such a way that they come in counter current they are clockwise and anti-clockwise. One is moving clockwise, one is moving anti-clockwise, and that's why the entire housing is there in the machine cell is there. So in the compression spring, we adjust this compression spring, and with the help we can crush the thing. You can compare this crushing roll just with the help of your sugarcane juice, local sugarcane juice production. So these are the two rolls you might have seen, and they are the material is going there. They are counter. One is moving clockwise, one is moving anti-clockwise, and the material which is there, and that fellow is adjusting that screw. So you can see, you can just connect with this thing with that crushing rod. You can say that sugarcane juice machine is similar to the crushing rods. Okay, I think you might have got the essence what we are going to give you. The basic principle you must know, and the basic diagrammatic representation you must go for. Now moving to the grinding. Grinding is intermediate and fine. It may be it reduces the crust feed to powder. The product from an intermediate grinder might pass a 40 mesh screen. Most of the product from a fine grinder would pass a 200 mesh screen with a 74 micron opening. The grinders may be hammer mill, which works on the which is impactor basically, rolling compression mills, they may be ball mills, roller mills, attrition mills, revolving mills, and the revolving mills can be subclassified into the rod mills, ball mills, pebble mills, tube mills, and compartment mills. So this was the grinding mills. You can say we have classified the grinding. Please learn about these mills. It is not possible to cover each and every mill. I request all of you to go through these mills, see their diagram, construction, and try to connect it with the machine which you are seeing in your day-to-day life. This will be more useful in connecting your ideas and understanding that particular mill in the better way. Now hammer mills. Hammer mills, which it contains a high-speed rotor turning inside a cylindrical case. The rotor carries a collar bearing a number of hammers around its periphery. By the rotating action, the hammers swing through a circular path inside the casing containing a tapered breaker plate. Then feed passes into the action zone with the hammers driving the material against the breaker plate and forcing it to pass through a bottom mounted screen by gravity when the particles attain a proper size. So what is happening? Series of hammers, you can say, in the roller carriers, they are moving in the rotating action. The hammer swing through the circular path inside the casing, and just when the feed is passing through the action zone, the size is being reduced. So this was about the hammer mills. Let's see the diagrammatic representation of hammer mill. That what you can see, it is a feed tube. Okay, feed is entering from this place, and what is happening here, that the blades are there. These are the blades you can see here. Then this blade, they help in determining the degree of reduction based material on the basis of material being processed. Okay, machine casing is there. Machine casing is there, as you can see. What is happening, that the material which is coming, it is rotating in a motion, and these blades, with the help of this hammering, the second part, the lower part is the screen. It is a screen type. It helps regulating the particles output within a specific size range. So whatever the hammering is being done due to this circular motion, actually when the desired particle size is reached, it passes through this sieve like thing, okay, this screen, and enters into this with the help of fan, it is moved to the product discharge. Okay, the product is discharged and the product discharge is done here. So metal is moving, hammering is done in the circular, hammering is done in the circular motion, and when the desired particle size achieved, it passes through the screen, and with the help of these fan and product discharge area, the product can be discharged of that uniform size or desired size. This you have to, screen you have to adjust depending on the particle size, and the blade adjustment or the hammering and the speed must be adjusted with the with respect to the product required. Rolling compression mills. These are also known as tumbling mills. What is the principle of these machines? The ball mill works on the principle of impact between the rapidly moving balls and the powder material, both enclosed in a hollow cylinder. What we have done, we have put lot many solid balls into the housing casing, and the feed is also with there. So when these are moving, with the help of this motion and with the help of that pressure of those balls, the compression is done. So that's why it is called rolling compression. Rolling movement is there and compression movement is there. So at low speed, the ball roll over each other, and attrition, that rubbing action, will be the predominant. But so at low speed, rubbing action, that attrition will be predominant. So does in the ball mill, impact or attrition? So impact and attrition both are responsible for the size reduction. So impact is also there, the impact of that movement, and then rubbing motion due to the attrition. Both, the blending of both the forces or the combination of both the forces leads to size reduction in the ball mills or the rolling compression mills. Let's see in the diagrammatic representation that uh, in the low speed with sliding, okay, the impact is the predominant mechanism due to the balls, presence of the impact of balls, while in the high speed with centrifuging, balls are there. You can see balls are all over there in the periphery. They are all over in the periphery. So what is happening? Not only the impact, but also this motion. So when we correct the speed with cascading, then we will get this better combination of this impact and attrition. So impact will be also be there and attrition will be there. So you will have to correct this speed. The speed factor must be optimized to get the desired particle size. So ball mill at low speed is used for milling dyes, pigments and insecticides. Stainless steel balls are preferred in the production of ophthalmic and parenteral products. Due to compatibility issues, we want the compatible component. Other balls may lead to some contamination or other things, so that's why we use the stainless steel, specifically in the ophthalmic and parenteral products. Now, what are the advantages of this ball mill? It can produce very fine powder, and you might have seen in your laboratory. This is very common in pharmaceutical laboratories, in pharmacy colleges and departments. Ball mills are ball mill is used for both wet and dry grinding process. You can do the grinding process of wet and dry in both in the ball mill. Toxic substances can be ground as the cylinder is closed system. You don't need to, you will not be inhaling the thing, it is not exposed. So that's why when it is contained there properly, so even the toxic material you can handle with the help of ball mill. Rod or bars can also be used as grinding media, especially for a sticky material. You can utilize it for size reducing in the ball mill. The installation, operation and labor cost are low. So ball mills are, that's why quite popular, and you can say specifically with respect to the mid-size operations, it's quite good and cost effective. What are the limitations and disadvantage of ball mills? This is a very noisy machine because the balls are moving, and that movement creates a huge noise. It's a slow process. Soft, tacky and fibrous material can be milled by ball mill. Okay, these are some disadvantages. Okay, only the soft material can be done, because the impact should be able to bring about the change. If you will put the very hard material in the ball mill, it won't get that particular force to reduce the size with the help of that impact or attrition. So only the soft, tacky and fibrous material, they cannot be milled by the ball mill, because neither, is both the cases. Nor the too hard material can be done, but the material should be capable to be broken with the help of that impact and attrition. Secondly, it should not be too soft or tacky or fibrous material, otherwise that material will stick, and it won't get the force with the help of impact or attrition. So in both the cases, specifically the soft, tacky and fibrous material cannot be milled by ball mill. Attrition mills. These mills produce a narrow range of particles, okay, because with the rubbing motion we are having in this attrition mills, the low clearance and higher speed facilitate the production of fine particle size. Fine size particles we can we can get from this attrition mills. The plate mills led to development of the colloid mills. The main difference between them is the clearance between the plates and the speed of rotation. These mills are extremely used in case of shred, curl, granulate, grind, shear, twist, blend, rub. Okay, they can be used in many ways. Okay, for developing the finer size particles. As you can see the attrition mill here, what is happening, the feed is entered from this portion, and the stationary disc is here, and rotating disc is anyhow is contained in a particular that casing, and with the help of this attrition movement the discharge can be attained. The product of this required particle size can be received from the discharge end. Fluid energy mills. After covering these attrition mill, impact mills, attrition mills, now moving to the fluid energy mills. These are in this mill, fluid the particles are suspended in high velocity gas stream that fluidize there. Okay, elliptical or circular motion in the pathfinder. Particle interact with each other, they start striking each other, they are having the rubbing motion with each other. So coarse particles remain in circulation, okay, while the working product is 0.5 to working product you get 0.5 to 10 micron, and feed can be input into the 110 per hour. That too, it should be non-sticky, and 1 to 4 milligram of steam or 6 to 9 kilogram of air per kilogram of product we can have, or product can be obtained as they have as the discharge. Fluid energy mills, the feed to the mills need to be pre-treated to reduce the particle size to the order of 100 mesh, enabling the process to yield a product as small as 5 micron or less. Despite this, mills are available which are capable of output up to 4 milligram for with the high frequency. Okay, uh, even the output may be optimized as per the requirements. Okay, and if you want the higher output, you will have to go for the high-end machines whenever your requirement is like this only. So these are the fluid energy moves. What is happening? Let's see that solid inlet is there, and fluid inlet jets are there. Fluid is entering here, and due to this motion, the zone of turbulence we can see due to this turbulence, that fluid inlet allows this intimate contact, and that attrition is going on there. Due to this energy, the centrifuge, and due to the centrifugal action through the coarser particles out, it throws the coarser particles outward, and okay, and the finer particles, the classifier removes fine particles and fluid into this due to the centrifugal force, and yes, this moves the coarser particles at the outer one, and this, by this way we can have the good control over the particle size range. With the finer particles can be obtained with the better efficiency as compared to the other mills. Now, what are the advantages of fluid energy mill? The particle size of the product is small than that of produced by the another method of size reduction. The expansion of gases at the nozzle leads to cooling, uh, counteracting the usual friction heat, which can affect the heat sensitive material. So what we are doing here, when that movement of the gases is actually leading to the cooling, so the frictional heat generated is not that much, which can be which can be destroying the heat sensitive material. So that's why it is quite good for using with the heat sensitive materials or thermolabile materials. Since the size reduction is by interparticulate attrition, there is little or no abrasion of the mill, and so virtually no contamination of the product is there. For special cases with very sensitive material, it is possible to use inert gases. We can use inert gases even to avoid the any degradation. Having a classifier as an integral part of the system permits close control of particle size. We can have the close control of particle size and particle size distribution. Okay, uh, with these fluid energy mills. Friends, these are some of the further readings. As usual, we always recommend some of the good references for you. So these are some references. What are the takeaway message? What is the takeaway message we can have? Size reduction, bigger particles with the help of fire, with the help of energy, they can be broken into the smaller size of uniform size with as per the requirement. Size reduction is needed for improving the surface area, improving the solubility, improving the flow property, improving the mixing, improving the dissolution and absorption. Okay. Mechanism size reduction is by impact, it may be by attrition, it might be hammering and impact hammering. Remember these things. So just remember these all the processes, but how you can go through with uh, what are the mechanisms involved in the size reduction, whether impact is involved, compression is involved, attrition is involved, or cutting in is involved. You should go and select that what kind of mechanism you should go through for that particular material, and what are the factors which can influence the choice of size reduction equipment. So on the basis of the material, on the basis of desired properties or desired particle size range, you can go for selection. We have also seen that depending on the hardness, viscosity, its nature, stickiness, okay, and other properties, we should go for the selection of the material, selection of the mills, depending on the materials property. We should go for the selection of the equipment, and we study the size reduction laws, the basic 4 laws. Please go through these laws and learn their at least this definition, the equation by which they can be expressed. You must learn. Then the various types of size reduction machines we have developed. We have discussed a lot many machines, the hammer mills, the ball mills, okay, fluid energy mills, and these mills. For these mills, what is the basic thing you should do? Basic principle, number one. Number two, basic mechanism. Number three, the diagrammatic representation of this construction, and you can also show the process of going through the size reduction with the help of ray diagram of in that particular construction diagram only. And then rather than writing in the text, you better present in the form of ray diagram with the construction whatever the diagrammatic representation of that particular milling you are doing, and then give the advantages and the limitations of each and every equipment, and try to compare that the thing with the other one. Okay, and try to connect what I have told you, that roller compression I have told you, that try to connect it to the machines which you have seen there. And this is the ultimate thing, because with respect to pharmaceutical point of view, you can't go to each and every text dealing with the pharmaceutical engineering and other things, or the mechanical engineering, for learning these machines. But at least you can connect these things with your household or whatever you have seen in daily life, and learn their basic principle. This is utmost important. The various types of size reduction machine we have seen, and I request you to go through these basic aspects uh, of each and every machines, and prepare your notes and be ready for your exam. So thank you for being with us. Happy learning, and we are going to come up with some more lessons on pharmaceutical production technologies. Stay tuned. Happy learning.